Have you ever pulled a coin from your pocket and contemplated the incredible details on that small metal disc? The engravings, the inscriptions, the perfect symmetry. How is it that this work of art can be produced millions of times a day flawlessly? Today, I'm taking you into the mysterious world of the United States Mint. This is not just a place where metal is shaped, but also where trust, history, and collective belief are embodied. Interestingly, this process shares the same fundamental truth as the giant rye stones of Yap Island in the Pacific. The value of something comes from all of us believing in it. The journey of an idea to the perfect mold. It all begins with approval from Congress and the imagination of an artist. A new coin design is first transformed into a gigantic model in clay or plaster. This is the art part. The artist, like a sculptor, meticulously works on every curve, every shadow. Because every detail here will eventually come to life in that small piece we'll carry in our pockets. So how is this giant model reduced to the size of a coin? That's where the Mint's age-old magic wand comes into play. The pantograph. You might be familiar with those small machines that copy keys. The pantograph is a historical machine that works on a similar principle, but in a much more complex and precise way. Simply put, a pointed tip at one end scans the large model created by the artist. This movement is transmitted to the cutter at the other end of the machine, which then engraves the same pattern perfectly scaled down onto a much harder block of steel. What emerges is the master die. That is the starting point for all production. There's a crucial detail here. In my opinion, there's a very romantic reason why they still use these old machines when technology is so advanced. According to experts, the fluidity and spirit of the lines created by an artist's hand cannot be perfectly captured in the digital files that computer-controlled CNC machines transfer point to point. The pantograph, on the other hand, can transfer the flawless and natural curves created by the human hand directly into the mold. That's why even the world's largest mints continue to rely on these centuries-old machines alongside the newest technologies. In fact, historically, the secret of this machine was kept almost like a state secret to prevent counterfeiting. A metallic elixir. Raw material preparation. The molds are ready, but what about the body of the coin? Huge metal coils made of alloys of metals such as copper, nickel, and zinc arrive at the mint. For example, let's take the famous Abraham Lincoln cent. Actually, that familiar copper color is just a thin coating. 97.5% of the coin is zinc. The reason is simple, to keep costs down. But even here there is a balance. The thin copper layer on top both gives it that characteristic color and protects the coin to some extent from rust. By the way, did you know that the production of this iconic cent will be stopped by 2025, saving about $50 million a year? So even the lifespan of a coin can be shaped by economic realities. The incoming metal strip first passes through a rolling mill until it reaches the exact desired thickness. Then, machines that act like giant punches cut perfect circles from this strip. These round discs are called blank discs. The cutting scraps are immediately recycled because no metal is wasted in a mint. However, these discs are not yet ready for minting. They are hard and brittle. To soften them, they undergo a process called annealing. By being heated in a controlled manner at temperatures exceeding 800 degrees and then slowly cooled, their internal structure is softened so that they can be shaped. Because this process darkens their surfaces, they are washed and polished with acid. And the final preparation, edge raising. The discs pass through a special machine that curls their edges upwards. We can now call them planchettes. This raised edge is one of the most important protectors of the coin. It prevents the metal from overflowing during printing, facilitates stacking the coin, and helps preserve the detailed design in the center, as the edges are the first to wear down over time. So that simple edge you see is actually a masterpiece of engineering. A birth in a tenth of a second. High-speed printing. Now for the magic moment. The planchette is automatically placed between two steel dies. A modern high-speed press, using hydraulic or mechanical power, collides these two dies with tremendous force. This pressure can range from 150 to 200 tons. Do you know what that means? Imagine the weight of 200 elephants suddenly pressing down on you. Under this immense force, the metal doesn't crush. It behaves almost fluidly. In less than a tenth of a second, it fills every detail, from the finest line to the tiniest microtext, in the steel die. In an instant, an ordinary metal disc transforms into an official US coin bearing history, trust, and value. This moment is, in a way, the rebirth of the metal. The final check of perfection and journey to the world. each printed coin is immediately subjected to a strict check. This is precisely where the fascinating parallel emerges between the giant rhinestones of Yap Island and our modern coinage. Non-physical ownership. A rhinestone never moved. Ownership changed hands with an update in the collective memory of society. Our modern coin does change hands physically, yes, but its true value, the $1 inscription, doesn't come from its physical existence, but from the assurance it provides with the full faith and credit of the U.S. government. The money itself is merely a tangible representation of this abstract trust, just as the rhinestone was a tangible representation of a story. Different faces of security. Rhinestones were unstealable because they were in plain sight and their story was known. Our modern money, however, is at risk of theft because it is portable. In response, our system manages this risk with physical security measures, complex edge serrations, microtext, bimetallic structures, and most importantly, by making counterfeiting a serious legal crime. Security is no longer just encoded in collective memory, but in laws and technology. Inflation and control. The supply of rhinestones was naturally limited by the physical hardship of perilous ocean voyages. In the modern economy, however, the supply of coins is controlled by complex economic decisions such as the Federal Reserve's interest rates and monetary policies. The cost of production, which is often less than the face value of the money, is not a limit. What controls inflation is the credibility of the central bank and public trust in that institution. Conclusion. Money is a social contract. The process of minting coins in America is the pinnacle of humanity's effort to embody trust. We watch as a metal disc, through incredible engineering, material science, and logistical organization, transforms into a carrier of value-bearing numbers and symbols. But this journey reminds us of a final truth. Money has never truly been about metal or paper. From Lydia's earliest coins to Yap's giant stones, to the dollar in our pockets or the digital balance on our screens today, money has always been a tool of shared belief and a social contract. The massive presses and complex processes of the U.S. Mint exist, in fact, to preserve, strengthen, and give physical form to this ancient and fragile belief, much like the inhabitants of Yap Island once did with the stories they wove around a single stone. I hope this detailed explanation serves as an inspiring source for your video. If you have any further questions, I'm here.